So a video on resistor combinations. I want to do one a little bit more detail here. So series versus parallel. Series is when you go from one to the other without anything in the way. Okay. The way I used to do this when I used to give like live reviews is I would have basically like I'd have a student come up and basically, show like two people hand in hand, side by side, okay, just holding one hand each. Those two people would be in series with each other. If I had another person come up side by side, just holding one hand each, those three people would be in series. You're going one to the other without any other junctions in the way. So series is just one thing, but like one wire, nothing in the way. Parallel would be dancing partners. So parallel would be where they're on each side, two hands holding, okay? They connect on each side. So it splits and then it reconnects basically. And that's parallel. It splits and it reconnects. That's series and that's parallel, okay? Anything else is not, which means that you have to find series, you have to find parallel. So if you were to say get, some circuit like this, okay? The quick way to do this, I have to tell you right now, there is no quick way. Really, there's no really quick way. I'm sorry. Okay. So how do we do it? If you have a battery on the left, you start all the way on the right-hand side, and you're going to combine this. The goal is to get this all the way down to one resistor to figure out what this equivalent resistance is going to be. Okay. So looking at this picture overall, this is not a picture. To me, this is a circuit. There is current that's flowing through and splitting up and rejoining. But the main thing is right now is the question is, what is the equivalent resistance? What is this resistor to this resistor? Absolutely nothing. What is this resistor to this resistor? Absolutely nothing. You have to start and see what is clearly in series or clearly in parallel. Can you get from one resistor to another direct route, side by side, holding hands, or are they dancing partners? That's the way I remember it. Okay. So on the far right, these two are clearly in series. I can get from one to the other, no problem. Resistors in series you add together, 6 plus 6 gives you 12 ohms. So those two are a 12 ohm resistor. Now what do? You have to redraw the entire circuit. This is going to be a long video. Again, there is no quick way. You can dump it online, but ultimately you have to be able to do this on a quiz or an exam. Now, I don't expect this length of difficulty to be on like an exam because this takes a while to do, but you could get one that has several resistors easily. You have access to old exams. You'll see this. Let me double check everything now. 12, 4, 3, the 6, 3. See, even I got to be careful. And I will have a few little hiccups along the way that I'll be correcting because it takes time. 3, 9, 6, 3, 4. Just double checking. 3 and 4, 3 and 4. 3, 9, 6. 3, 9, 6. 12 over there. 4, 6, 4, 6, and 3. Okay, now I just did series. Normally what happens is you go back and forth and back and forth and back and forth. You find series, then parallel, then series, then parallel until you get down to one circuit, one resistor. Next up, what's in parallel? Where are my dancing partners at? From here to here, the 12 and the 4 are clearly in parallel. I go from one to the other. They are dancing partners. They're holding hands left and the right. What about this one? It's not. The 6 is in the way. What about the 6? It's not. The 3 is in the way. The 12 and the 4 are in parallel. So 1 over R equals 1 over 12 plus 1 over 4. 1 divided by 12 plus 1 divided by 4. Power negative 1. And I get 3 ohms. Okay. Next up, now I got to go ahead and redraw this whole thing again. Let's see, 3, 4. Three, 9, 6. Six, 3 on the bottom. And this becomes from this point to this point a 3 ohm resistor. How do you draw it? From this point to this point, using a 3 ohm resistor. I could draw it like this. I could draw it like this. I could even draw it like this. The point is you have a 3 ohm resistor from that point to that point along the circuit. Okay. Now I just finished with parallel. Next up is series. So series looks like going from here to here. It's clearly in series. Add them together. 3 plus 3 will give you 6 ohms. Now, with enough practice, if you choose to practice enough, or I mean, again, just take some practice, you might be able to do this all, not this many resistors, but you might be able to like in just in your head and just combine, just use your calculator, find the equivalent resistance. But that takes some time and practice. From here to here, I have now one equivalent. So from here to here, I've got a 6 ohm resistor. Draw it however you want. I'm going to draw it like this. Let's see. How am I doing so far? Okay, that was series. Next up, parallel. Do you have any dancing partners? Yes. From this point to this point, those two are in parallel. They meet on end to end. What about the 3? Well, the 9's in the way. What about the 6? Not even close. Hey, are these two in series? No, because it splits up. You've got to be able to go from one to the other with nothing in the way to be in series. And you have to be dancing partners, meet hand in hand on each side to be in parallel, just to remind you. So those two are in parallel. 1 over R equals 1 over 6 plus 1 over 6. So equivalent resistance, again, I know how to work this, but I'm double checking with my calculator, is 3 ohms. Okay, here we go. 3, 4. And yes, I know I had a really good opportunity, by the way. I was thinking before I created, so I was going to do like 6, 7. But anyways, 3, 4. Sorry, I had to mention it. Let's see, 3, 9, 6. And now from this point to this point is one equivalent 3 ohm resistor. Those two are in series. Which two? Once again, I can get right from here to here. So that in series, 3 plus 3 is going to give you 6 again. Okay, next page. Typically on an exam, I expect one resistor combination, one capacitor combination, one that might use some part of Kirchhoff's rules, and one RC circuit. So usually there's like 4 questions historically. 3, 4, 6, 9, 6. Just double checking everything. Cool. Mm, Just double checking. Again, going back through everything. 3, 9, 6. Now it's 6. Okay. So these two are in parallel, but I'm just double checking everything now. hmm 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 Okay, moving on. These two are in parallel. So between those two is going to be 3.6. Again, from this point to this point, I need one 3.6 ohm resistor. Those two are in series. Add them together. Ah! Between these 2 points, those two got combined to one 9.6. Now these two, 4 and the 9.6 are in parallel. and I get something pretty like 2.82 with a bunch of decimal places. And then lastly, those two are in series. So the final equivalent resistance added together is about 5.82 ohms. That's the effort. That's the patience. That's the double checking, the triple checking that's required for something as complex as this. I do not expect you to get this complex come exam time. This is a pretty standard homework type question that I wanted to make sure that you saw step by step.